We are going to be looking at how you might use slope in kind of a real life situation. So this is asking you to find the rate of change. Rate of change is another word for slope we learned about. So basically this is saying find the slope, okay, between the years 1970 and 1850. So what I'm going to do is I'm going to notice that on the map all the years are on the x-axis. So I am going to find the population for 1970. So I'm going to go to 1970 and I am going to, not 1970, 1790, sorry. I keep saying 1970. 1790, I'm going to go to 1790 and I'm going to find the population. So I'm going to go to this coordinate right here and I'm going to think about making a coordinate of it. The years will be your x-axis. So the numbers that are down here will be your x. So this is the coordinate 1790. And then I need to look at the population, and I know it's kind of hard to see, but this would be 10 million people, and so then this coordinate right here would be 5 million people. So 5 million people. Okay, so that's that coordinate. And then I'm going to go to the year 1850. So 1850 would be right here. Okay. And that is the coordinate 1850. And then the population of that, if you look across, is about 25 million, I would say. Okay? So when you do your slope or your rate of change, again, you have to do difference of y's on the top over difference of x's on the bottom. So you would go, in this case, 25 million minus 5 million over the difference in years. So 1850 minus 1790. And I know these are not pretty numbers, so we just kind of have to deal with it. But you're going to get 20 million over 60. Okay? And that, of course, can reduce if you put that into your calculator and then hit math enter, you will get 1 million, I'm running out of space here, over 3. Okay? So this would be your rate of change, but you need to really kind of think about what that means. So what that means, on the top, remember, we put our populations, okay? So on the top, we put our populations. On the bottom, we put our years. So what that really means is that the population grows. It's a positive number, so I know that it's growing by 1 million people approximately every 3 years, okay? That's what that means. All right, very similarly is this one. So now I'm looking from 1960 to 1990, okay? So 1960, if I look across, that is 180 million people. So I have one coordinate, and I'm going to go down here this time so I have some more space. I have one coordinate that goes 1960 and 180 million people. Okay, then I'm going to go back up to the graph, and I am going to go to the year 1990. So I will go to 1990 on the graph, which is right here. And I look across there, and it's about 250 million people. And again, not pretty numbers, but we can handle this. Okay? So I want the change in the population on top, so I will go 250 million minus 180 million over my change in years on the bottom. And since I started with 250 for my population, that was in the year 1990, so I have to start with that on the bottom. And that reduces to 70 million people over 30. And then if you hit math enter, you can cross one of those zeros out, which would be 7 million people every 3 years, because again, on the top we had people, on the bottom we had years. So that means that the population grows, since it's positive, by about 7 million people every 3 years during that time frame.